So again, Chris Vantine, Chief Technologist for the Western region at Red Hat. I work with strategic partners and customers, primarily in Silicon Valley, who are adopting Red Hat's emerging solutions around enabling technologies, including containers and DevOps. Today's talk is about enabling innovation, accelerating it for the business, and talking about the security implications as you move to a DevSecOps environment based on containers. But to start it out, let's talk about some of the industry drivers. Andy Grove talked about how only the paranoid survived back in the 90s. And this isn't about security, but it's about how there's massive amounts of change sometimes in the industry. And a company is faced with a challenge and decision. Do they adapt and pivot their direction in order to potentially thrive? Or do they stay the course and potentially fall by the wayside? In many different industries, companies are faced with this challenge right now. The incumbents are being disrupted by these disruptors, and software is enabling these new companies to stay ahead of the competition and revolutionize their industries, whether it's Amazon and retail, Apple and Square and finance, Netflix and the media, etc. No industry is left untouched. And how does the typical enterprise keep up? Right? It takes the typical enterprise 6 to 9 months to deliver new innovation. When these disruptors are delivering new innovation every couple of weeks, if not every day. And as I talk with companies in the Valley, most of them are faced with this challenge where they have the development, the QA, and the operations teams have evolved in independent silos. And just like in nature, if you evolve on your own, you come up with your own language, your own tools, your own processes, and it becomes very difficult and challenging to move an application from dev, test into production. And so there's a lot of pressure on IT not to become the bottleneck for the business. And so IT must change. In order to deliver innovation in a matter of days or weeks, there's an evolution in how development processes are and a movement towards DevOps, eliminating those walls that typically sit between dev, test, and production. And as a result, in order to move efficiently from dev, test, into production, that monolithic application needs to be broken down into independent microservices that are loosely coupled. The reason for this is that you no longer need to bet the entire business, potentially their survival, with a major release. Instead, these independent microservices can be updated on their own and evolve naturally. Also, these smaller microservices, no longer does it make sense to rapidly deploy in a physical server or a large virtual machine. You need a lightweight container, right, that can start up quickly and can be built once and deployed anywhere, whether it's dev, test, production, as is. And being able to deploy that container on physical, virtual, private, or public cloud. And so, looking to the manufacturing industry, does anybody recognize what this is a photo of? Right, this is the Intel fabrication plant that's being built currently in the United States. And I show this because back in the 90s, does anybody recall the Pentium bug? Right, the Pentium bug was a flaw in the Intel processor. And as a result, Andy Grove reflected on this and realized not only can they rely on the physical factory, the fab, to be a strategic differentiator, which consistently allowed Intel to stay ahead of the competition, but they also needed a software factory behind this that they could rapidly respond to issues in the marketplace and customer feedback and improve the overall quality of the chip design process. And so he built out a software factory, tens of thousands of Linux servers today, which allow the chip designer to design their small component of the overall chip and then submit it to an automation, a continuous validation farm, and get immediate feedback of whether that component works together with the others. And so continuous integration, a key part of DevOps and a key part of Intel's differentiator. Also another factory, does anybody recognize this one? Right, this is the Tesla automobile factory. And I show this because it's representative of another key part of DevOps, continuous delivery. For the first time, you can buy a car and it gets better over time because they can continually deliver updates over the wire, improving 0 to 60 time, battery efficiency, or the applications on the center console. Also, fundamentally expanding the business model. No longer is it a one-time sale, but now they can have a subscription service. Think about autonomous driving coming down. Security updates. You need to be able to rapidly deliver these updates to the vehicle. And so, DevOps is all about breaking down those walls, but it's not just technology. Culture is a key component. Bringing together dev tests, operations, the business, security teams. Also, process, continuous integration, continuous delivery. But a key component is getting that constant feedback and being able to quickly respond, right? Being able to deliver software in a matter of days or weeks is an allow the business to be ahead of the competition and a key differentiator. And of course, the technology is a key part, and as folks are adopting DevOps, open source is a key choice, whether it's Linux, containers, the infrastructure layer, or the development platforms and tools. They're leveraging open source to build out what I call this software factory, allows you to rapidly innovate for the business. And so what about security as you transform your organization to this new way of rapidly innovating? And so when I joined Red Hat, initially as I talked with companies in the Valley, they would talk about security and kind of a blank stare as to what is their process when it comes to security, because they didn't have one, right? If the server didn't sit in the DMZ, they weren't patching it. And simply, this process cannot continue. As you've seen in headlines across the globe, security issues are faced by numerous companies. These represent over 1 billion data records that were compromised in 2014 by some of the marquee names in the United States. And so security needs to be embraced in all aspects of your DevOps transformation. Culture, security first mindset, integrating into the process so you're constantly scanning your environment for security compliance, security audits, and then also leveraging tooling in your CI/CD pipeline. And containers are a big part of this transformation because they allow, from a security perspective, they allow IT to free up the developer and allow them to innovate at their own pace. They can include the key components that they need without being hindered by security compliance policies from the operations and security team, because they can abstract their application from the underlying host. And the typical container process is the build, ship, and run. From a security perspective, I can use a build file as my recipe for building out a container image. This allows me to go back in time and reproduce this exact same image. I can also, once I produce this artifact through my build process, I can store that image in a registry and allows me to share that container across all my environments, dev, test, production, physical, virtual, private, public cloud. That way, I build it once. The developer builds it in a production-like environment on their laptop. That same environment could be a virtual instance in your test as well as in production. And then lastly, I run that container in a standardized runtime environment, similar to the Java world, where you have a standard image file and a standard image runtime. That allows you to take any container image and run it anywhere as long as you have that standard runtime. But when it comes to containers, there's more requirements and capabilities required to deploy containers at scale. What about scheduling, lifecycle and health, discovery, monitoring for that continuous feedback loop, the ability to automatically scale up, down, persistence, aggregation, and of course security. And so that's where the Kubernetes project comes in from Google. Right? Google open source their container technology, a container application platform based on a decade of experience and has become an industry standard across many different industries and companies as a part of their container management solution. And Kubernetes brings out-of-the-box security across the board. And we're going to talk a little bit about how you can do that. So first off, when it comes to container security, here are the types of questions I'm hearing from customers. Are there known vulnerabilities in each application layer of the container image? Are the runtime and OS layers up to date? How frequently will the container be updated, and how will you know when it's updated? Is the image from a trusted source? Can I quickly deploy a security update at scale? And is my multi-tenant host secure? So we'll talk about these in the remaining slides. So when it comes to security, here are some key areas you want to consider in locking down your environment. Container hosts, images, builds, registry, CI/CD, and in the bottom row, network, storage, API access, monitoring, logging, as well as federation. So first, container host security. So first off, containers are Linux. Containers are a key part of the Linux kernel and in the capabilities of C groups, namespaces, NSC Linux. These are some key technologies providing security for your container environment. First, C groups is providing quality of service so that you can have multi-tenancy and that each container is restricted in the amount of resources they're consuming so you don't have a noisy neighbor problem. Also, namespaces provide that logical view for the container so it looks like a complete system. And you also don't have the issue of having a root user in a container being the root user at the host, and therefore if there's a security compromise, jeopardizing the security of your entire system. And then SC Linux provides mandatory access control so that your container process explicitly is defined as to what files, objects it can actually access, even if it's root, so that you don't have the issue of a compromise being a vulnerability across the board on your environment. And so here, from a host perspective, here's some best practices around locking down your container host in your cluster environment. So first off, don't run your containers as root as the best practices. Many require that out of the box. So as you build out your container image, put that restriction in there. Also, limit SSH access. If you need data, build a API service to get that data from that container. Also, make sure you're using namespaces for the reasons just mentioned. Make sure you're defining quotas and limiting what these containers can consume. Also, enable logging across your container environment so you have an audit trail. And be sure to apply security rata, not just to the container image, but also the hosts in your environment. And of course, SecComp filters allow you to restrict the capabilities that your process has so you can provide further harnessing of your container. Also, container image security. Let's talk about that. In the container, it's a little bit different, and it's a difference that you need to understand coming from the current world. Maybe in your Java application, the developer is providing operations with an application, their Java code, and a jar file. Well, as you move to a container environment, not only is the developer providing the application, but when you build that container, it's pulling in the dependencies for the runtime, as well as some libraries potentially for the operating system. So from a security perspective, now that container is not just the application, but also who's going to look and update the runtime layer as well as the OS layer that's in that container. Right? And so the Docker file allows you to have a common language and a common tooling across the board. Today, you may be using a kickstart file to build the OS for the core build, and the middleware team may be defining their application platform, providing that in a zip file, and then the application code may be in a jar file. Well, in a container, you can normalize that all with the build file, and then the application owner can request the standard middleware image in your environment that's been maintained by your middleware team, and then that can be built upon the core build provided by your operations team. And so in this model, each group owns the security for their respective layer. So as an application owner, I don't need to be aware and following security updates at the middleware or the OS layer. And so the security implications for a container, it's important to understand, at a deep level what's going in there. Here's an example of some containers. On the left, it's a C application, then a Java, Node.js, and a PHP. And these orange boxes are the different components that got pulled in when I built my container image for my application. So take the second one, is a Java. It pulled in the JRE, Bash, and glibc, some OS and application platform components. The little triangle represents the number of security issues that have been released for RHEL 7. So the JRE has had 66 and counting security issues. So the lesson here is when your developers are pulling from a public repository, you as an organization need to be aware of the security implications, not just the day you pulled it down, but an ongoing basis. So how are you going to address that? You need an ongoing scanning process. Right? And so also treating your containers, if you're building out new applications, a best practice is to treat them as immutable. What does that mean? Limit the code to the container image. Pull out any configuration in your data and treat that separately. If you're using a Kubernetes for container management, you can use config maps and secrets to store the configuration. For data, you can use data services or the persistent volumes, which come integrated into the platform. Also, another best practice for container images, make sure you're signing them. Right? Therefore, is it coming from a trusted source? Right? Check that signature. And also, you could have a hook, so when your container images are launched, to make sure you only launch images that are signed from a trusted source. Right? Container registry security. Right? So as your developers are pulling down images from the Docker Hub public repository, be mindful that a lot of these images have security issues. We did a scan, 64% of them had high or medium security issues. Right? So a best practice in your enterprise is to set up a private registry. That's pretty much step one as customers adopt containers, is I see them setting up a private registry for their developers to access trusted content and to store internal images. You have an audit trail, you can access control. Also, developers are typically putting in their build file third-party dependencies. If those third-party dependencies are on a public registry, what if that public registry isn't there in 6, 12 months down the road? How do you reproduce that version when you're troubleshooting a customer issue that's on a legacy version? Right? You want to store that in a private registry, then you own the process for backing up, restoring, etc., ensuring that your business has a recovery plan for legacy environment images. Also, what about continuous integration with containers around security? Right, so this is what the typical CI/CD process pipeline looks like from a security perspective. You have your developers and operations checking in their Docker files, their code into some source code repository like Git. And then you have a build environment. The key thing for your build environment from a security perspective is to make sure that your container images are reproducible builds. And how do you go about doing that? Well, one is you don't build your image in the same image that you're building. So instead, use a build image and then produce a secondary image, the artifact, that actually has your application in just those immediate dependencies that it needs. That way you keep it lightweight, and then also you can make it reproducible every time if you have kind of a clean room build environment, similar to the fab. and then store that image into your private image registry. You build it once, and then deploy anywhere. And the nice thing is, with a container application platform, you can also build these virtual instances of your environment, so you're providing a production-like environment on the same physical infrastructure, or on a separate infrastructure that's an exact clone. So I'm testing and trying things out as a developer on an environment that mirrors my production environment. I'm able to eliminate the issues early on and greatly reduce my technical debt. Another best practice around builds is, treat the build file as a blueprint so it's reproducible. Don't log in to a container image, make changes, and then save it, because you're not going to be able to reproduce that when that engineer leaves. Also, put the build file in a source code repository. When you're defining what third-party components, make sure you're specifying the version and not just latest. And then be mindful that every time you add a run line, it's creating an additional layer, so you want to be mindful of that. Also, we talked about an ongoing process for security scanning your container images. Here's a typical build pipeline that your developers are using. You have build 1, build 2, build 3, and then the different phases, and showing you the progress and the success. Well, what you want to do in a container CI/CD pipeline is add a phase for security and run a security scan on your container image that was just built by your development team. And then also, how about ongoing updates? I, as an application owner, I don't want to be tracking middleware or OS security issues. So what I can do is I can either write scripts or leverage embedded technology to actually trigger automated rebuilds. So you can monitor the registry. If you see an update to the core build or middleware that your application depends on, you could trigger an auto rebuild of your application and then move it from dev test into production through your automated CI/CD pipeline, or you could have manual steps as well. Right? And so how would you go about doing that scanning? Well, OpenSCAP is an upstream open source tool you may want to consider for compliance and vulnerability audits. So OpenSCAP provides a security policy guide to lock down your container images. It also provides a vulnerability list so that you can scan and see if any of your RPMs have known vulnerabilities. It provides a daemon CLI to be installed in your environment. And then it produces reports that provide compliance scoring both at a vulnerability and compliance level. And so these reports can be used for auditing, and also it provides remediation. And so out of the box, support from many different Linux OSs, it comes out with predefined security guide and policies, whether it's for your JRE, your Docker host, or your generic Linux system, your virtual system, etc., or some government guidelines as well. And so these policies can be applied and scanned for on your physical system, your virtual system, or your container image, whether it's at rest or a container instance. And so here's an example of the security policy report. It shows the pass fails, maybe your password length wasn't set correctly in the container image. And then it also provides a script. It now includes an Ansible script to actually remediate the issue for you. And then also provides a report on vulnerabilities. So these are RPMs that have known vulnerabilities and need updating. And so it can update it with the proper new version for your distribution. Right, what about CD with containers? Right, this is continuous delivery. So this is a key conceptual change, is that in a typical environment today, you go out and patch your production servers because it takes months, if not years, sometimes to release major updates. And with a CI/CD pipeline, you now have the capability for your business to deliver updates in a matter of hours, days. And so when you have a security issue, you want to go back to step one, right? You want to build it in your development environment, push it through test, put it through that security scan, and then have an automated way to deploy that update at scale. And we'll talk about some of those methods. So today, you build your jar file, you move it through QA, staging, and production. In a container environment, you build the entire container image with your application and your OS inside the container, those dependencies, and then you move the entire image from QA, staging, production as is. You're not rebuilding it, right? So if there's a production issue, you go back to development and add that security patch. And so you need some deployment strategies to quickly get those updates into production at scale. And so some deployment strategies you want to consider are blue-green deployments, rolling updates, and canary deployments, as well as do some A/B testing. And so you can either script that or you can leverage your container application platform like Kubernetes to manage that for you. So what is a blue-green deployment in a container environment? First off, you have version 1 in production. Your developers are working on 1.2. Instead of the same environment, you've created an entirely new virtual environment for that new version on the same physical infrastructure. You then run your automated CI testing, and when it's completed, you simply automatically update the software load balancer and route the traffic to that new version. If there's an issue, you can immediately roll it back to that virtual environment for hosting version 1. Also, you have the ability to do rolling updates with zero downtime. Right? This is where you have version 1 spread across your cluster. You have a new version that has a new security patch, version 1.2. It's in a separate test environment. When it completes testing, you can go ahead and gradually roll out the new version one by one. And you want to check using a health check, readiness probe, before you bring online that new version by updating the software load balancer after it completes that health check. And so here, as I gain confidence in that new version, I can gradually roll out the new version by replacing the old version with the new version until it's 100%. That way I have zero downtime and I can quickly get that security update deployed at scale. Right, so securing containers, we covered container hosts, images, builds, registry, and CI/CD. There are also other areas of interest, network isolation. You want to have the ability to have multi-tenancy, and that requires separate networks, sometimes depending on your security requirements. So leveraging software-defined networking is a great way to accomplish that. Storage, you also want to make sure that you're restricting access to your shared storage and mapping that appropriately to the individual containers that are allowed to access that storage. For your API, you want to make sure that you're locking down the API so it's not wide open for people to create and deploy containers across your environment. And then having a centralized monitoring and logging is very critical from a security perspective, as well as just a general CI/CD so you can quickly respond to changing conditions, evaluate that, and then make adjustments and pivot and move forward. And then federation provides a great way to have different security environments to meet different requirements on different providers. So maybe you have, in dev, you have a more loose security policy on your internal environment, and then your test environment might be on a public cloud with a different security standards depending on what type of application it is. And then also your production environment may be on your private cloud with yet another security policy. So you want to bring that together and have a single view. So federation is a great way to manage that scale. So as you make this transition, you may ask, your management may ask, how are we tracking towards our transformation goal of improving our ability to innovate quickly in the marketplace? And from a DevOps perspective, here are some metrics you may want to track. First off is, from a security perspective, our compliance score for your security policy, as well as vulnerabilities. How often are you deploying to production? What's the lead time to go from dev into production? What's the failure rate? How quickly can I recover? Right, this is a key metric as you move away from those monolithic apps so you can quickly recover and not have to bet the whole business every time you deploy a new version. And then certainly, track your service availability from a business perspective.
Oh.
And that's all I had today. So thank you so much. Short on time from a question standpoint, but you can see my LinkedIn here, my email, as well as Twitter. Feel free to reach out. I'll be around outside in the lobby. If you have any questions, look forward to chatting with you. Thank you so much.
Thank you, Chris. And as always, we're giving, you're no exception. We're giving you our little something to remember us by. Thank you.